GFCI, Ground Fault Circuit Interrupters. Standards of Practice. The InterNACHI Home Inspection Standards of Practice at nachi.org/SOP requires the inspector to inspect all ground fault circuit interrupter receptacles and circuit breakers observed and deemed to be GFCIs using a GFCI tester where possible. History. Since the early 1970s, GFCIs have been required in an increasing number of damp and wet locations. Recently, this requirement has been extended to all receptacles in garages. Because they are safety devices, the home inspector should check every installed GFCI circuit and may advise the client of areas where they should also be installed. Charles Doziel, who lived from 1904 to 1986, a professor of electrical engineering at the University of California, invented the ground fault circuit interrupter, or GFCI, in 1961. He came to realize that a common cause of death was the result of ordinary household circuits malfunctioning in the ground fault. His research objective then became to create a device that would interrupt a ground fault current before it became large enough to cause human physiological damage. The sensitivity, speed of action, reliability, small size, and cost required made the device almost impossible to design. However, in 1965, Doziel received a patent for a ground fault current interrupter that would interrupt current before it grew to 0.005 of an ampere, and which was small, reliable, and inexpensive. The device was based on a magnetic circuit plus a then newly developed semiconductor device. Most of the time, his invention does nothing. It just monitors the difference in the current flowing into and out of a tool or appliance. But when that difference exceeds 5 milliamps nominal, an indication that a ground fault may be occurring, the GFCI shuts off the flow in an instant, in as little as 0.025 of a second. How does a GFCI work? GFCIs are designed to sense any difference in current between the supply on the ungrounded, hot conductor in a circuit and the grounded, neutral conductor. If the circuitry recognizes a differential of more than 5 milliamps nominal between supply and return, a solenoid trips open the circuit, causing all power to be disconnected. For this reason, a GFCI breaker or a correctly wired GFCI receptacle can protect all outlets farther downstream. Types of GFCI devices. There are 4 basic types of GFCI in common usage, and 2 or 3 of them are common in residential construction. They are 1. GFCI breakers in the distribution panel, 2. GFCI receptacles at in-home locations, 3. Standalone GFCIs as sometimes used with pools, and 4. Extension cords with built-in protection primarily found on construction sites. GFCI on 2-wire circuits. There is a common misconception that GFCIs work only on grounded circuits. This is not entirely the case. While there are conditions under which the GFCI will not be able to trip within a ground, the inspector should still recommend that any circuits in potentially wet or damp locations be fitted with them as a safety precaution. GFCI location requirements. Refer to 2021 IRC E3902. Please refer to Section E3902 of the 2021 IRC that relates to GFCIs and AFCIs. An arc fault circuit interrupter, or AFCI, protects people from arc faults by recognizing characteristics unique to arcing and by de-energizing the circuit when an arc fault is detected. A ground fault circuit interrupter, or GFCI, senses any difference in current between the supply on the underground hot conductor in a circuit and the grounded neutral conductor. If the circuitry recognizes a differential of more than 5 milliamps between supply and return, the GFCI trips open the circuit, causing all power to be disconnected. For this reason, a GFCI breaker or GFCI receptacle can protect all outlets downstream. GFCI protection is recommended for the following: 15 and 20 amp kitchen countertop receptacles and outlets for dishwashers, 15 and 20 amp bathroom and laundry receptacles, 15 and 20 amp receptacles within 6 feet of the outside edge of a sink, bathtub, or shower, electrically heated floors in bathrooms, kitchens, and hydromassage tubs, spas, and hot tubs, 15 and 20 amp exterior receptacles, which must have GFCI protection, except for receptacles not readily accessible that are used for temporary snow melting equipment and are on a dedicated circuit, 15 and 20 amp receptacles in garages and unfinished storage buildings, 15 and 20 amp receptacles in boathouses and 240 volt and less outlets at boat hoists, 15 and 20 amp receptacles in unfinished basements, except receptacles for fire or burglar alarms, 15 and 20 amp receptacles in crawl spaces at or below ground level, and 15 and 20 amp receptacles in indoor, damp, and wet locations. Bathroom. To protect people, ground fault circuit interrupter, GFCI protection, should be installed in all bathrooms with 125 volt to 250 volt single-phase 15 and 20 ampere receptacles. All bathroom receptacles. A bathroom is not necessarily a room. It is an area that includes a lavatory, wash basin, and a water closet, toilet, and a tub and/or a shower. There are no exceptions for the GFCI requirement in bathrooms. All bathroom receptacles would include, for example, a receptacle in a light fixture, a receptacle for a clothes washer, or a receptacle for any appliance installed in a bathroom. Bathtub and shower stall receptacles. All 125 volt single-phase 15 and 20 ampere receptacles located within 6 feet of the outside edge of a bathtub or shower stall must have GFCI protection. No receptacles are permitted to be located within bathtub and shower spaces, but they are permitted to be located outside of those spaces with no minimum distance requirement. Person in a shower or bathtub could reach a receptacle that is less than 6 feet from the outside edge of the shower or bathtub, and by doing so would create a shock hazard. Garage and accessory buildings. To protect people, GFCI protection should be installed at all 125 volt single-phase 15 or 20 ampere receptacles installed in garages and grade-level portions of unfinished accessory buildings used for storage or work areas. Even a tool shed or a storage shed must have GFCI protection. Where an appliance, such as a food freezer or refrigerator, is plugged into a receptacle in the garage, that receptacle must be GFCI protected. In the past, there was an exception for an appliance that caused nuisance tripping of the GFCI, but this exception is no longer allowed. Outdoor GFCIs. There must be at least one receptacle outlet installed outside at the front and back of the house that has direct access to the ground surface, and those receptacles must be readily accessible from the ground surface and not located higher than 6 feet 6 inches above the ground surface. Here's a common situation. If there's a deck at the back of the house and it does not provide stairs from the ground level to the deck surface, then the receptacle at the deck area must be accessible from the ground level, assuming it's the only receptacle in the rear of the house. To protect people, GFCI protection must be installed at all 125 volt single-phase 15 and 20 ampere receptacles installed outdoors. The exception for GFCI protection is for outdoor receptacles that are not readily accessible and are used for temporary, non-permanently installed snow melting equipment powered using a dedicated circuit. A receptacle installed outdoors should have an enclosure for the receptacle that is weatherproof when the receptacle cover is closed and an attachment plug is not inserted. Outdoor deck outlet. Balconies, decks, and porches that are accessible from the inside of the house are required to have at least one receptacle outlet installed within the perimeter of the balcony, deck, or porch. This receptacle must be located no higher than 6 feet 6 inches above the surface of the balcony, deck, or porch. All outdoor receptacles, including those on the balcony, deck, or porch, are required to be GFCI protected. At least one receptacle outlet must be installed outside at the front and rear of the house that has direct access to grade level, and each must be readily accessible from the ground surface and not located more than 6 feet 6 inches above grade. If the balcony, deck, or porch is accessible from only inside the house, there must be at least one receptacle that is accessible from the balcony, deck, or porch, and it must be located not more than 6 feet 6 inches above the balcony, deck, or porch surface because it has to be reached from the ground level. Refer to 2021 IRC E3901.7 outdoor outlets. Laundry. To protect people, ground fault circuit interrupter or GFCI protection should be installed in laundry rooms with 120-volt single-phase 15 and 20 ampere receptacles. This includes receptacles used for laundry appliances. There are areas in the laundry room where people can contact grounded conducting surfaces, grounded water piping, and grounded appliance housings. A hazard may exist where people put themselves between a voltage source and a grounded object or surface. Crawlspace. To protect people, GFCI protection should be installed at all 125-volt single-phase 15 and 20 ampere receptacles in the crawlspace when such place is at or below grade level. The 120-volt lighting outlets located in the crawlspace should be GFCI protected too. If there is a receptacle in the crawlspace, it must be GFCI protected. Unfinished basement. To protect people, GFCI protection should be installed at all 125-volt single-phase 15 and 20 ampere receptacles installed in unfinished basements. Unfinished basements are defined as portions or areas of the basement not intended as habitable rooms, such as storage or work areas. The exception would be a receptacle supplying only a permanently installed fire alarm or burglar alarm system. Kitchen. To protect people, GFCI protection should be installed at all 125-volt single-phase 15 and 20 ampere receptacles that serve countertop surfaces. Any countertop receptacle, even in an area far away from the kitchen sink, is required to be GFCI protected. Kitchen dishwasher branch circuit. In the kitchen, people may create a shock hazard by putting themselves between a voltage source and a grounded surface or object, such as a dishwasher. GFCI protection must be provided at branch circuits that supply dishwashers, whether the appliance is hardwired or cord and plug connected. A GFCI type circuit breaker or a GFCI receptacle device can be used. It's common to find a single, not duplex, receptacle for the dishwasher mounted in the back of an adjacent kitchen sink base cabinet. This allows the dishwasher to be slid in and out of the cabinet space. It is good practice to provide a single, not duplex, receptacle for the dishwasher so as to discourage occupants from using an open receptacle mounted inside a cabinet. Indoor damp and wet locations. Receptacles installed in indoor damp and wet locations must be GFCI protected. A damp location is protected from weather and not subject to saturation with water or other liquids, but subject to moderate degrees of moisture. Examples include partially protected locations under canopies, marquees, roofed open porches, and interior locations subject to moderated degrees of moisture, such as some basements, some barns, and some cold storage buildings. Damp, protected. A wet location is underground or in concrete slabs or masonry in direct contact with the earth. Wet locations are also subject to saturation with water or liquids and in unprotected locations exposed to the weather. Water is dripping, splashing, or flowing. Wet, unprotected. Sink. To protect people, GFCI protection should be installed at all 125-volt, single-phase 15 and 20 ampere receptacles that are located within 6 feet of the top inside edge of the bowl of a sink. This applies to all sinks in the kitchen sink, laundry tub, bar sink, utility sink, garage sink, etc. And the GFCI protection is for all laundry receptacles, including the ones used for appliances. Receptacles should not be installed in a face-up position on the countertop or work surface. Boathouse. To protect people, GFCI protection should be installed at all 120-volt single-phase 15 or 20 ampere receptacles installed in boathouses. Boat hoist. To protect people, GFCI protection should be installed for outlets supplying up to 240 volts at boat hoists. Electrically heated floors. To protect people, GFCI protection should be installed at electrically heated floors in bathrooms, kitchens, and in hydro massage bathtub, spa, and hot tub locations. GFCI locations. GFCIs should be installed in readily accessible locations. Testing GFCI circuits. GFCIs and AFCIs must be installed in readily accessible locations because they have test buttons that should be pushed periodically. Manufacturers recommend that homeowners and inspectors test or cycle the breakers and receptacles periodically to help ensure that the electrical components are working properly. Many manufacturers state that their devices should be tested by using the test and reset buttons on the breaker or receptacle. Many common circuit testers will not be able to trip a GFCI installed on a 2-wire circuit, as most testers actually trip a GFCI by creating a partial fault to ground. Obviously, if there is no ground to energize, then the neutral will not be able to sense any voltage drop. The manufacturers state that their equipment should be tested by using the test and reset buttons on the breaker or receptacle. However, many inspectors usually check them with their GFCI receptacle tester. Some testing devices check not only that they trip, but also measure at what voltage they trip. However, the best way to test a GFCI is by using the button on the breaker or receptacle itself, as recommended by the manufacturer. Equipment grounding is not necessary for a GFCI to function properly. The grounded person becomes the equipment grounding conductor, and the current going through them creates the imbalance that trips the GFCI. This is why GFCIs are allowed to replace open ground receptacles without adding an equipment grounding conductor. Any breaker or receptacle that fails to trip and reset properly should be reported as a defect and written in the report as in need of correction by an electrician or qualified contractor.